So here we're ready to do the third lab tutorial for ANOVAs. To enter your data, you're going to start in the variable view as always. In this study, we're working with 3 variables. We've got sex, age, and happiness. We're going to treat sex as a nominal characteristic, age also as a nominal characteristic, and happiness as scale. We're now ready to enter the data. Oops, I lied. We're going to enter value labels first. We'll use 1 for male and 2 for female. Of course, you can do it the other way around. For age, I'm going to say that 1 is young, 2 is middle-aged, and 3 is older. All right. Now we're ready. When I type a single 1, for whatever reason, my version of SPSS puts in 11. That's really annoying. You can just delete one of the 1s and it will behave as it should. I don't know what causes it, but it's not that hard to work around. And then let's see. So I've got my 18 participants there. The ages, these guys are all young. These guys are all middle. And these ones are all older. Happiness, 30, 31, 32, 33, 31, 32, 34, 33, 32. Am I doing this right? Female, middle-aged, 45, 43, oops, 43 and 42, 34, 33, 31, 60, 65, and 63. All right, so there's my data. Notice that I can turn the value labels on or off. It's easier, I think, to have them on, but that's just me. Your analysis is going to come out the same way no matter what. So since we are working with sex and age, just by their very nature, we know that those cannot be within subjects' variables, at least not if you are. The only way for that to be within subjects is if you're following the same individual over time. There's no indication that that's the case in this study, so we're going to assume that these are independent samples, and we're going to need a regular Factorial ANOVA. We don't need to use repeated measures for this design. So we're going to go analyze general linear model and univariate. There we have happiness is our dependent measure, and then our fixed factors are sex and age. It doesn't matter what order you put them in. In order to get all of the right options that we want, go ahead and select options and select the marginal means, all 3 of them. What I just did there was hold down shift click, but you can click each one individually and select them over. We're also going to want descriptive statistics, estimates of effect size, observed power, and the homogeneity tests. This one is critical for testing the assumptions of ANOVA. We're also going to want plots, so we want to see what the data look like in a graph. It doesn't really matter which one you put on the horizontal axis and which one you plot as separate lines. I'm going to put age on the horizontal and separate lines for sex. Critically, after you've done this, you have to click the Add button in Plots, or else you won't get anything. All right, so once we have done that, we are fine for now. Notice that if you want to plan post hoc tests ahead of time, you would do that here in this window. I'm not going to do that for the moment. So we've set up our ANOVA, click OK, and it chugs along and produces some nice output for us. Here I'm just doing some checking to make sure I have the right number of participants in each condition. So I've got 9 and 9, that's what I wanted. 6 in each age bracket, so again, that's what I wanted. That looks good. I might this is the point where I would go hand calculate the means, perhaps, just to make sure that I didn't make any errors in entering those happiness data. But for this tutorial, I'm going to assume that I did that part okay. Here are my descriptive statistics, means and standard deviations for each combination of factors and levels. So we've got 3 levels of male, and then the grand mean for male, 3 levels in female, and the grand mean for female, and then, of course, the grand mean overall. This thing, the Levine's test for equality of error variances, that is what tests the null hypothesis that our variance is equally distributed across the groups. And here it's showing us that this test is significant. That means we're going to reject that null hypothesis of equal variance across the groups. This is not a result that you want to see. That means that you're going to have to do some sort of correction to make up for the fact that the variances in your groups are not equal. That's a bummer. Ideally, you would have equal variances, which would mean that this value would be large, such that we would not reject that null hypothesis of equal variance. For now, I'm going to proceed as if we had found that there was no significant difference here. So I'm going to continue as if we were working with equal variances. What I get next is this table that says tests of between subjects effects. This is the ANOVA output that we are most interested in. And here are those middle 3 lines that we care most about: main effect of sex, main effect of age, sex by age interaction. So we can follow along the main effect of sex. We have a big F value, 184.26, significant at p less than 0.001. Remember that this is never actually p equals 0. SPSS is just telling you that it is less than 0.001. And we have a very large partial eta squared. That's a measure of effect size. And we have very large observed power. Similarly, we have a significant main effect of age, also p less than 0.001, another very large effect size and large power. And then finally, we also have a very significant sex by age interaction. Again, p less than 0.001, big effect size, and good power. When we look at the marginal means, this is sort of telling us the direction that each of our effects is going in. Here, this tells us about the main effect of sex. We find that females are reporting more happiness than males overall. This is collapsing across all ages. Here, looking at our main effect of age, we see young participants reporting less happiness than middle-aged, who were in turn reporting less happiness than older participants. So that's the direction that our main effect of age is going in, collapsing across both genders. And then here, if we just try to understand our interaction by looking at the numbers, it becomes a little bit, at least for me, a little bit overwhelming. It's a lot easier to see in a graph. So here's where we get that plot, where we can see in the young, at the young age level, there's not a very big difference between males and females. We would have to do a simple effects comparison to see if that individual difference is significant or not. The difference between males and females gets a little bit bigger in middle-aged, and then by old age, there's a huge difference between males and females. So our interaction is coming from the fact that this male-female difference is getting bigger and bigger over time. Similarly, you could say that the age effect is changing, the age effect differs for males and females. Okay? That's how you get your data, and then everything from that point on, I believe, is covered in the how-to document in terms of giving you an SPSS write-up. So I think I'm going to leave it there. Good luck.